right, hi everyone. We'll let some folks get settled and we're going to go ahead and get started. I'm Jacob DePriest. I'm the Deputy CISO at GitHub, and I've been here about just under 18 months.
Cool, and I'm Greg Osa, and I'm our Senior Director of Product Security Engineering at GitHub, basically managing all the things we do across the development lifecycle to bring security to our products, both from preventing and finding and fixing security vulnerabilities across the board in the features and products that we ship.
So thanks for joining us today. We're going to switch in and out and talk a little bit about how we use GitHub to secure GitHub. So it's probably no surprise to any of you who've used GitHub, but at GitHub, we believe really deeply in using the product to build the product. And so really across all of the teams, both technical and non-technical at the company, we use GitHub for almost everything. Today, we're going to focus in on 5 areas in the security team where we use GitHub a lot, and it really shapes kind of how we approach our security posture at the company. So first, we're going to start with identity and access management. So we are developer focused. We have customers. Many of you in this room are our customers. From a security team perspective, our customers are also the developers in our engineering team and our product team. And so when we think about identity and access management inside of the company, we wanted a capability that allowed us to keep our developers in the flow and be able to kind of do the things that we need them to do, but also meet all the needs we have. And so we were thinking about this. We thought, like, what are the requirements? How are we going to approach this? We need to be able to show compliance in audits. We need to be able to handle things like reorgs. We need transparency and scalability, but we also need to handle risk. So not all the things that we're providing access to are the same risk level. And so we landed on being able to do this inside of Git. And so we use repository-based access control system, effectively Git Ops, to do this for the entire company. And this is how we manage our IAM at the company. This is a program we call entitlements. So we're going to talk a little bit about that. So what's it look like in practice? So let's say that you switch jobs inside the company and you need access to a new, let's say Splunk in your new team, and maybe you didn't have access to that before. Well, we just open a pull request. So you would open a pull request in the repository where we manage our entitlements. You would find the right file, whatever the Splunk access you need in this case is. And then you open a PR, add your handle to it. And then you wait on the approvals. And then that's where our automation kicks in. And depending on what you're trying to do, depending on the sensitivity of the actual capability, it will require certain levels of approval. Some of these are app level. So in the case of Splunk, maybe the team that owns and manages Splunk, maybe they have to approve it as well as your manager. Maybe it's just your manager, and we can kind of move that quickly. Once that's merged, all the things kick in the back end, and you have access. How do we handle things that are a little more sensitive? So this kind of brings us to the strictly audited entitlements. And so this is a capability where, let's say it's production VPN, or let's say it's super admin on one of our SaaS tools that we use. We really want to control that. That's not something we just kind of want that. I mean, we want the self-service capability, but we also need to make sure that we've put increased kind of rigor around that. And so we have a set of entitlements that are strictly audited. And what this enforces is a periodic review. Usually it's 6 months. And an automatic expiration. And so what happens is every 6 months, it kind of comes back up and says, hey, we need you and your manager to reaffirm that you need this access. If it doesn't, then it's just going to go away. We also kick some of those things in when we have a reorg automatically as well. So this is, the entitlements capability is open sourced. We open sourced this a few months ago. And I'm going to click there we go. And so it's available as a kind of core capability. A couple of things we open sourced as well were plugins that work with external features. So you won't be surprised, we open sourced a plugin for GitHub. So kind of like from the workflow perspective, how this works is whatever your source of truth is as an org chart, however you're kind of managing your HR system, that's where that comes in. That's going to produce a machine readable file. We ingest that into entitlements, and then based on the hierarchy and kind of the manager and employee reporting chain, we update permissions in GitHub, and then we push it to an identity provider, which then will, maybe in some cases, would use SCIM to provision that access across our SaaS platforms. And so this all happens automatically and through Git Ops. So it's very transparent, and our auditors love that because we can actually go through the PR and merge history and show exactly where and when everything was done and approved and merged. All right, so on to number 2, so security findings. I know we've had some really good conversations with several of you this week about security findings. Every company and every kind of team that's dealing with security, I think, has this challenge of where do we deal with and how do we aggregate all the things that are coming into the security team, right? So it's not just CVEs, it's also things like bug bounty reports and PIRs from incidents or availability incidents, security incidents. It could be things from the red team. And so how do we think about that? How do we handle it? How do we do that? Well, at GitHub, we have GAS, and we use GAS internally, so GitHub Advanced Security. So we use all those features and all those tools. One of the things we love about that and developers love about that, it's integrated into how they're doing their work in the repositories every day. But how do we do that with all the other stuff that we have coming in? And so we have built an internal tool that we're using called Security Findings that really emulates that flow for the things that aren't part of Advanced Security. And so this could be things like a bug bounty report. It could be something from our cloud security posture management tooling. It could be something from our red team. Our red team is actively always probing the infrastructure and the product, looking for gaps. And so we funnel all that into security findings, and we pair that up with our fundamentals program, which is an internal program where we track things like durable ownership, and it's kind of the baseline requirements for the company for availability, for performance, and security. We marry all that up, and then we put it where developers do their work, which is GitHub issues. And for us, we use Slack a lot. So it might show up in a Slack message depending on how urgent it is and how we need to track it and remediate it. And then that gives us that accountability and visibility we need for SLA management and being able to essentially make sure that the resources are in the right place, but we're also meeting our internal needs, our stakeholder needs, and our customer expectations. So security findings is how we're approaching that problem. Sorry, I'm going to put this down and just use the clicker. So just to give you a sense of the scale here, last year, and these numbers are notional, but just to give you a sense of scale, we had in the millions of detections that come in every year. And we have to triage those. And so a lot of that triage is automated. We do have some humans doing some of that work as well. That might result in some findings. That's still a huge amount of numbers that we have to deal with. And we don't want to push out 500,000 issues to developers at GitHub. We would be a very unpopular team if we did that. So really, we get all that down into a consolidated view, and that translates to in the thousands of issues. That's what we end up opening up, and then give the developers the consolidated view, give them a sense of the priority of what they need to do and how we need to remediate it, what the SLA is, and they can work on it. One of the things that we're working on now is a UI that goes with that. And so the reason for this is sometimes we want to be able to provide more data. It's not required. We're still going to open an issue where developers work in the repo that they're doing their work. But sometimes a CVE can be complicated, or a security finding can have multiple CVEs. And so instead of, in some cases, opening up hundreds of issues on a developer repository, what we'll do is open an aggregate issue and then point them back to the security findings UI, where we're providing data, we're providing things like the lifecycle, more data on the actual vulnerability, and remediation status and history of remediation. So it was fixed by the developer and the team, then it was reverted back, and then it was fixed again, and we can see all that in the flow. And so this is how we're doing our best as a security team to lean into how GitHub does work internally, which is all in GitHub, and pulling the findings that are important to us, important to our customers and auditors and stakeholders into that developer flow. All right, I'm going to turn it over to Greg.
Cool. Thank you, Jacob. And today I want to kind of follow up on what Jacob was just talking about how we track findings, how we track vulnerabilities, and really focus on one specific type of vulnerability and work through some of those workflows. So like I mentioned, I run our product security engineering team, where we're working to prevent and identify vulnerabilities. But one of the things that my team is also responsible for is how we respond to vulnerabilities once we're aware of them. And in part of this, we want to make sure we run a consistent process through our product vulnerability response and make sure we're handling things in a consistent way. And to do that, we really kind of run through a bit of a life cycle for everything we get in. And we want to make sure that we have great ways to intake to make sure we're aware of vulnerabilities that are coming through. We also want to make sure that we're doing the right things when we're aware of that to make sure it's fixed, where we know it is, where it's fixed, places we might not yet know if there's a variant of that vulnerability. And then finally, once we fix the vulnerability, it's really important for us to make sure if our customers need to take action on getting that fixed in their environment, like something like GHES or in an open source project or library that they're utilizing, that we disclose that vulnerability to ensure everyone can pull in the proper fixes and understand the urgency in which they need to do that. And all of these things, really, kind of our workflow, again, goes where our developers are. We move all of this into issues and work with our engineers where they're working for any other bug fix. So for kind of the first step is looking at the intake. We have a bunch of disparate sources where we might become aware of a vulnerability in our product. We run a very popular bug bounty program. We're also now rolling out our usage of private vulnerability reportings on GitHub for some of our open source libraries. So another way to get in vulnerabilities reported in our software. We also have some more traditional means like a security at email address. And we're monitoring a bunch of things. If someone reaches out into Twitter, not the best way to get information about a vulnerability, but we're still monitoring those things. So we have a really good awareness of all these external sources of vulnerabilities. And we also have internal sources of vulnerabilities. Maybe an engineer is working on a feature, they're doing some development, and they come across something. We want it to be very clear where they go to report that to make sure we're thinking about it and we're running through this process. And like Jacob mentioned, we have a bunch of other security teams also finding vulnerabilities day in, day out. We have a red team looking at things. I have an assessment team that's doing code review, doing security pen testing, and all of that. So we want to handle all these vulnerabilities in a really consistent way. And how we do that is all this intake is kind of coordinated by an incident responder. So one of the teams underneath in PSE, Product Security Engineering, is our PCERT team. And what they do is they monitor all these sources. So we have awareness of all of these different places for intake and to make sure that we're actually routing them to the right teams. We're given the right context around what is the issue, is this actually an issue, and what team should own it, and what code base does this affect. So that's really kind of our triage process here. And really what this looks like is to get it in front of our engineering teams. We know it's an issue, it's a vulnerability in our code. Let's open that up where our engineers are doing all their other development, right, alongside other bug reports, so they can properly prioritize and track that work just like they would any other engineering work. So our product security incident responder then opens up an issue. And we can see here kind of an example of something that came in through a bug bounty report, specific vulnerability, and kind of the different things that we add from that. So we're pulling in all of the context of what's the issue, is there a proof of concept, any additional analysis that our triage team might have done to validate that or ask additional questions from the reporter to really get all of that context so we can present that to the engineering teams when they're starting their fix. We also give it a severity, and this really helps set expectations and SLAs and timeframes to help engineers prioritize this work alongside all of the other engineering work they're doing. Kind of the next step is once we have that out there, we've started the discussion about what the vulnerability is. The next step is getting that fixed, getting that remediated where the issue is. And this always, just like any other bug, we go from an issue, we go to a pull request. And a pull request gives us that great opportunity to pull in some security engineers to make sure the fix that's proposed is complete. There's not any weird edge cases or bypasses, and we're really thinking about, is this a robust fix against the vulnerability that was identified, making sure we have test cases, all of that, making sure all of that goes into the pull request that we have, and getting that really deployed to where the vulnerability is at. You can see here, even after the vulnerability has been fixed in one place, let's say it's deployed out in production, we also need to think about what else do we need to do with that vulnerability. And there's still a couple steps left. One of the things we can see here, right, it's fixed, but we're asking additional questions like, does this affect GitHub Enterprise Server? That's a different deployment model where we then need to get that into GitHub Enterprise Server. And we also follow up if it came in through the bug bounty saying, what's the severity, what's the payment for that, and bring that into the issue just so we have a really clear and transparent decision making, making sure that we're coming up with payment amounts through our bug bounty program that are equitable and in line with what we've paid before and meet our severity guidelines. So I mentioned we fixed this in the code that we knew it impacted. One of the big steps that we always do is where could have this vulnerability or this type of vulnerability affected other code? And this might just be in the same code base, but this might also be across our code bases, right? If we have some weird edge case of a SQL injection, right, we're going to want to look for that across all of our code bases. And this is what we call variant analysis. And there's a couple tools on GitHub that we use. Today, just announced, was the integrated code search. And this has been huge just for really quick and easy. Like, I can create a regular expression. I can look for this code pattern, across all of our repositories. Now, I'm going to say I'm in a very lucky spot because I know all of our code is on GitHub. GitHub developers develop on GitHub. So I have a pretty holistic view across our organization in where code lives and the ability to search through that. I think the cool thing is outside of code search, we can even do better. We can use CodeQL to really model these vulnerabilities, to look at our code paths and say, is this actually taking in user input, and build these CodeQL rules. And the cool thing about this is I have a team, our code analysis team, that's looking at these vulnerabilities we have coming in, seeing, can we write a CodeQL rule for this, and then running that CodeQL rule across all of our code bases that we have code scanning enabled. And it really allows us to give us that holistic view of other variants of this vulnerability that might impact our code. And finally, I think the next step and the final step, like I mentioned, is we fix this. We feel good that this type of vulnerability, we have great coverage. We've looked across our code bases. We need to make sure our customers and the users of that code are aware if there's any actions they need to take to actually mitigate that. For open source, this is great. We use GitHub Security advisories. If it's an open source library or vulnerability in one of those, we go through the GitHub Security advisory process to cut a CVE, to get that CVE published, and then Dependabot does its thing and alerts all the users of that vulnerability. It's really great. For things that impact our products, we're actually a CNA, a Certified Number Authority, for our products. And largely this looks like GitHub Enterprise Server. And since this isn't an open source product, we run our own process to get CVEs published for GitHub Enterprise Server. To do this, we loved the flow of GitHub Security advisories and the collaboration it brings. And we have our own process that kind of mimics that internally. So if we've decided a CVE needs to be issued for GitHub Enterprise Server, we go through kind of this templated issue. And to submit a CVE to MITRE, you need to have a very specific JSON formatted file that then you send to them. And we have a process that goes through where we can collaborate on a pull request very, very nicely in a YAML formatted file. And then we have GitHub Actions run that actually then converts that into the schema, the JSON schema that's required by MITRE. So after that's done, we can actually create a pull request to MITRE's repository with that CVE under the block for our CNA, and then get an advisory published for GitHub Enterprise Server to make sure then customers are aware through their own vulnerability scanning of if they're running an outdated version of GitHub Enterprise Server, what the risk is, and allows us to really go through that whole notification process and make sure they're aware. So one last item I wanted to touch on is what we're using our product for to do our security reviews. And security reviews are a way for security to have awareness, to give input, and to do any of the downstream reviews and assessments and analysis of the products and features we're shipping in a centralized manner. So engineering teams and product teams know how to engage us. And one thing that we're utilizing for this is, again, it's on GitHub and it's in an issue, but what we're using is our issue template forms. And what that allows us to do is really gather structured information about a product or feature that's shipping, both just general information, so we have the context of what it's doing, what concerns, what risks there might be, who to contact about it, and things like this. But it also allows us to gather really structured information, like multiple choice answers, that help us figure out what the risk of something is, help us get an idea of maybe some of the concerns we might have. Because really what we're looking to do in this process is, as you've seen today, GitHub ships a lot of things. And how do we prioritize our security resources to really focus on the most important things or the riskiest things. And by collecting this information, and then we run GitHub actions against these issues to pull out this information and calculate a risk score, so we can use that in our conversations, in our own prioritization and structuring. So again, here we can see, a team came in, opened up an issue, filled out their information about some of the features of their new product, new feature area. And then we go through and calculate a risk score, and you can see here, this is a medium risk score, and that's going to play into how we prioritize those downstream reviews, what we're looking at. Are we doing, a code review of this? Are we going to do a private bug bounty on this? And helps us really kind of understand the next steps for that product feature. And with that, I'm going to hand it back over to Jacob to wrap up with some Git Ops for managers.
All right, thanks, Greg. So we could talk probably for the next 4 hours about how we use GitHub in the security team, but we can't leave out managers as well. So we're going to spend the last couple slides chatting through that. I started out as a developer in my career, and now I'm a manager. And so I think there's a lot of folks at GitHub who've had a very similar transition, and we've kind of taken our love of automation and using the developer tools into the management practice as well. So one of the things that is core to kind of how we think about work every day, I know a lot of you can identify this, is never force a human to do what a robot can. I think that was pretty true in some of the announcements you saw earlier today as well. So a couple ways we do this is through issues and projects. And so this is very similar to what we've talked about already, but it's really focused on how do we run our programs, how do we think about strategic planning, and then how do we build in kind of our business processes into the GitHub flows that our developers use every day as well. And given that so many of us were developers, this is just a very natural extension of how we think about our work. So we start with issues, we link those issues and pull requests, and then we see all that take shape in projects. And then we often use, which we'll talk about next, actions to pull it all together. So here's an example of a few quarters ago where we do all our OKR planning at the company in GitHub projects. And so one of the ways we do this in terms of tracking is we have a project board for the security team, and each one of those OKRs is mapped to an issue. And then what we don't want to have happen is we don't want to have developers go to 6 or 7 different places every quarter or every 2 weeks to provide an update. We want that all to be streamlined in and as easy as possible to provide updates kind of in the flow that they're in every day. And so one of the things that this example does is a developer can kind of go into an issue where they're doing the work and create an update in one place, and then actions will kick off and then update the project board with the status, with, is it gone from blue to green, green to red, is there a blocker, or have we shipped it? And it can update that all automatically, so we don't have to go into multiple places. And so this is another way we do it kind of in sort of after what Greg talked about in terms of the security reviews. A security review gets submitted, one of the other teams may want to know, does their team need to look at it based on the risk score that was calculated by the action on the intake? Well, we also have actions that will pull those in from the security review repo, kick off actions, and then add them to internal tracking boards so that individual teams, maybe it's the security operations team, maybe it's the security architecture team, they need to look at those in more in depth, syncs all those together and creates that automation so that folks don't have to go in and triage essentially every single thing that comes in, only the ones that apply to their space. So just to wrap up here, I think we've talked about this a bit, but we're a globally distributed working team, and working async for us is imperative. GitHub has that built in, and that's why we use it for so many things, from what the security team is doing every day to what our managers are doing. And that's not just how our managers work in security, this is how our managers work across the company as well. And we have a diverse set of employees, and this is how we've kind of chosen to lean into building the product, using the product to build the product. And then when things aren't working the way we expect, we give that feedback back, and we have that tight iteration loop. And so really appreciate the time today. And I think we've got some time for questions. Yes? We have some mics we can share as well? All right, awesome. We've got one down here.
Okay without the mic?
Let's do the mic so that the folks tuning in virtually can also hear the question, if that's okay. If not, if it's people in the middle, I can repeat as well.
Thank you. So how many security developers do you have to help support the size of your development organization? Like what's the ratio?
So I'll let Greg talk about this a little bit as well. I mean, we have security developers kind of split all around the company, and so it's not like a direct number. So we have security engineers focused on the product and building the product that ships. We have a security team that's focused on the securing the actual kind of back end of the infrastructure and then doing the reviews. But they also, in Greg's team, we do kind of a pin scaling, if you will, so that if we add more engineers and product folks in another part of the company, we make sure to scale Greg's team up with that at a certain ratio so that we don't get into a situation where there's so many things coming in, the security team can't grow with it. We've got one back here.
Hey, thanks. You guys started out by talking about IAM a little bit and how you work with that with GitHub. One of the challenges we have faced is in automation. When we're automating things with GitHub, the lack of service accounts is definitely something we've had to do some weirder things. And I'm curious how you guys have solved that problem and how you guys control automated access to resources in GitHub.
That's a good question. So the short answer is we can spend some time after this and maybe we can get a whiteboard because it is complicated space, right? We have a lot of things that go into that in terms of how we control the service accounts. Some of it is through entitlements and how we leverage that, and then some of it kind of comes down to the roles and the access that we grant into those things. So we use a lot of the internal tools that are built into GitHub. So we use the PATs, we limit the access to things, but we also have kind of sensitive things like in the entitlements, we'll only tag certain teams, or like certain things that need access will require a VP to approve depending on how sensitive it is. And so it really depends on the access itself and how we've kind of got it wired up behind the scenes. But that's sort of the front door to make sure that we've got the appropriate oversight and approvals in place before it goes into kind of what is happening in the infrastructure behind it. Anything else? We've got 2 more minutes. Got another one down here? All right.
So you mentioned a lot of custom actions that will trigger to run various business processes. What kind of development process do you use for those? Are they just like one-offs that somebody creates, or is it do you treat it as like any other piece of shipping software?
That's a really good question. It's both, really. So it depends on how complicated it is. So if it's an action that is going to have significant access to our infrastructure or our SaaS platforms or things that we're really integrating in, it's going to have a more rigorous review through our security review process. If it's just wiring up, maybe a repository to a project board and there's no actual sensitive access at play, it may just be something we would ship and iterate really quickly in an afternoon. Some of it is we're leveraging open source packages that are in the marketplace as well. One of the things that we do work very closely on with our developers is when using something like that, we want to make sure that we pin to a SHA and not just a tag, so that when we kind of do the initial review and we're happy with the security of it, we kind of pin to that so that if it gets updated out of band, we don't get surprised by what gets put in there. We've got another one back there and then one more up here.
So you talked about your risk review, right? Like risk ranking, and based on that, how frequently do you recalibrate that?
I think we're always recalibrating it, right? I think when you're looking at what information can we collect and what signals are we getting out of there, I think it's always an iterative process. And we're keeping an eye on what that looks like. There very much might be a new area of risk that we've seen frequently. It's like, okay, we should really start making sure we're aware of the features or products that are shipping with that and hone on that. So I think it's always an iterative process on that. I wouldn't say we're always looking at that, how we can make improvements, how we can get better signal out of it, because as we shipped the first version of it, it was very much of like, let's throw this out there, see what it looks like, and see what we need to iterate on and change on that to get better signals or different signals that we hadn't thought of yet.
I think we have time for one more down here. Yes? No? Okay. All right, I think we're at time. Thanks, everybody. We'll be around after this if anybody has more questions.